Hello students, welcome to this lecture one surface areas and volumes. Okay, so let's start. So from class 9, you are familiar with some of solids like cuboid, cone, cylinder and sphere. Okay, so that is shown in figure 12.1. So this is cuboid, this is cone, this is cylinder and this is sphere. So you are familiar with this some solids in your class 9. So we have also learned how to find their surface areas and volumes. Okay, so in this lecture we will discuss surface areas and volumes of some combination of solid figures. Okay, so in our day-to-day life we come across a number of solids made of combinations of two or more of basic solids. Okay, so sometimes we can combine sphere with cone, we can combine square, so we can combine cuboid with sphere. Okay, so in our day to day life, we come across a number of solids made up of combinations of two or more of the basic solids. Okay, that is shown in this figure. So in this figure, you must have seen a truck with a container fitted on its back. Okay, so this is our figure 12.2, and in this figure we have seen that a truck with a container fitted on its back and carrying oil or water from one place to another place. So is it in the shape of any of our four basic solids mentioned above? So is it in the shape of cuboid or cone or sphere or cylinder? Okay, that are actually basic four solids that we have mentioned our previous slide. Okay, so you may guess that it is made of a cylinder with two hemisphere as its ends. Okay, so this is actually a cylinder with the two hemisphere as its end. Okay, so again you may have seen this figure. So you may have seen an object like like one in the figure 12.3. So can you name it? So in this type of figure, in this type of object, you may use in your science laboratory. Okay, so this is actually called a test tube, right? So this is a test tube. So you would have used in one in your science laboratory. So this tube is also a combination of a cylinder and a hemisphere. Okay, so at this end point here, it this is actually hemisphere and this is cylinder. So this object, this tube is actually combination of a cylinder and a hemisphere. Similarly, while traveling, you may have seen some big and beautiful buildings or monuments made up of a combination of solids mentioned above. That is the solids cuboid, cone, cylinder, or sphere. Okay, so we in our day-to-day life we have seen some big big and beautiful buildings or monuments that made up of a combination of solids mentioned above. Okay, so now if for some reason you wanted to find the surface areas or volumes or capacities of such objects, so how would you do it? Okay, so natural question arises: how would you find the surface area or volume or capacity of such objects? Okay, so we cannot classify this under any of the solids you have already studied. Okay, so in this chapter basically we will see how to find surface areas and volumes of such objects. Okay, so of such combination of solids. Okay, so this is our motive of this lecture. So let's start. Surface area of a combination of solids. Okay, so now we discuss this topic, surface area of a combination of solids. So let us consider the containers in this figure. Okay, so how do you find the surface area such a solid? Okay, and how whenever we come across a new problem, so we first try to see if we can break it down into smaller problems so we have earlier solved. Okay, we can see that this solid is made up of a cylinder with two hemispheres stuck at either end. Okay, so if we combine these two hemisphere and these cylinders, then basically it will give you this figure. Okay, so this object, so it would look like what we have seen in figure 12.4. After we put the space if we after we put the pieces well together, then we get this figure. So if we consider the surface of the new form object, so we would be able to see only the curved surface of the two hemispheres and the curved surface of the cylinder. Okay, that you have studied in your previous class in class 9, how to find curved surface of hemispheres and how to find curved surface of the cylinder, that you have studied in your previous class. So we can, first of all, we can find their curved surfaces. Okay, so the total surface area of new solid is basically the sum of the curved surface areas of each of the individual parts. Okay, so this gives us the total surface area of new solid, that is TSA of new solid. This is equal to curved surface area of one sphere, that is CSA of one sphere, plus curved surface area of cylinder plus curved surface area of other hemisphere. Okay, so there are at ends there are two hemispheres. Okay, that is why we take curved surface area of one hemisphere, and we also take curved surface area of another hemisphere. Okay, so total surface area of new solid, that actually combination of two hemispheres and a cylinder. Okay, that is equal to curved surface area of one hemisphere plus curved surface area of cylinder plus curved surface area of other hemisphere. Okay, so now where TSA, CSA stand for total surface area and curved surface area respectively. Okay, so from now you can stand TSA for total surface area, you can stand CSA for curved surface area. So now let us now consider another situation. So suppose we are making a toy by putting together a hemisphere and a cone. Okay, so let us see the steps that we would be going through. Okay, so so first we would take a cone and a hemisphere and bring their flat faces together. Okay, so here of course we would take the base radius of the cone equal to the radius of the hemisphere. Okay, this must be taken. So first of all, we would take a cone and a hemisphere, and we here would take the base of radius of the cone equal to the radius of the hemisphere. Okay, for the toy is to have a smooth surface, so the steps would be shown in this figure. So first of all, we take cone and we take hemisphere, and we take the radius of face radius of cone is equal to radius of the hemisphere. And if we now adjust, if we now together take together, okay, so then it will become like this. Okay, so this. So at the end of our trial, we have got ourselves a nice round bottom toy. Okay, so now if we want to find how much paint we would require to color the surface of this toy. So what would we need to know? So we would need to know the surface area of the toy. Okay, so if we know the surface area of this toy, then we can find the required color of this surface for painting this toy. Okay, so the surface area, total surface area of this toy, this which consists of the curved surface area of the hemisphere and the curved surface area of the cone. Okay, so we can say total surface area of the toy, this is equal to curved surface area of the hemisphere plus curved surface area of cone. Okay, so now let us consider some examples for clearing this concept. Okay, so now we will explore some examples on this topic. So here we take first example. So here Rashid got a playing top that is known as Lattu, okay, as his birthday present, which surprisingly had no color on it. Okay, surprisingly it had no color. That is, Lattu had no color. So he wanted to color it, okay, with his crayons. So the top is shaped like a cone surrounded by a hemisphere. So you can see this figure 12.6. So the entire top is 5 centimeter. Okay, so entire top is 5 centimeter in height, and the diameter of the top is 3.5 centimeter. So the diameter of the top is 3.5 centimeter, and the total entire top is 5 centimeter in height. So we need to find the area he has to color. Okay, so we need to find the area he has to color. So take here pi is equal to 22 by 7. Okay, so we here take pi is equal to 22 by 7. So now the top is exactly like the object we have discussed in figure 12.5. So you can see 12.5 figure, and that actually this top is actually exactly like the object we have discussed there. Okay, so we can conveniently use the result we have arrived at there. Okay, that is total surface area of toy. This is equal to curved surface area of hemisphere plus curved surface area of cone. Okay, so now the curved surface area of hemisphere, this is equal to half times surface area of sphere. That is pi r square. So surface area of sphere is pi r square. So area of a curved surface area of hemisphere, this is half of the surface area of the sphere, that is equal to half into pi r square, and this is equal to 2 pi r square, and this is equal to 2 into 22 by 7 into 3.5 by 2 into 3.5 by 2 centimeter square. Okay, so the curved surface area of the hemisphere, this is equal to 2 into 22 by 7 into 3.5 by 2 into 3.5 by 2 centimeter square. And now versus the height of the cone, this is equal to height of the top minus height or radius of the hemispherical part, that is equal to 5 minus 3.5 by 2 centimeter square, and this is equal to 3.25 centimeter. So the total the slant height of the cone L is equal to square root of r square plus h square, and this is equal to square root of 3.5 by 2 whole square minus plus 3.25 whole square, and this is equal to 3.7 centimeter approximately. Okay, so therefore the curved surface area of cone, this is equal to phi r L, where r is radius of this radius of the base circle of this cone, and L is the slant height of the cone. Okay, and we find the slant height of the cone L is equal to 3.7 centimeter approximately, and now the curved surface area of cone, this is equal to pi RL, this is equal to 22 by 7 into 3.5 by 2 into 3.7 centimeter square. Okay, and this gives the surface area of the top as 2 into 22 by 7 into 3.5 by 2 into 3.5 by 2 centimeter square plus 22 by 7 into 3.5 by 2 into 3.7 centimeter square. Okay, so the curve, the surface area of the top, this is equal to the curved surface area of the hemisphere plus curved surface area of the cone. Okay, and here curved surface area of the sphere is equal to 2 times 22 by 7 into 3.5 by 2 into 3.5 by 2. Okay, and the curved surface area of the cone is equal to 5 RL, that is 22 by 7 into 3.5 by 2 into 3.7. Okay, and if we calculate it, then this is equal to 22 by 7 into 3.5 by 2 into 3.5 plus 3.7 centimeter square, and this is equal to 11 by 2 times 3.5 plus 3.7 centimeter square, that is equal to 39.6 centimeter square approximately. So you may note that total surface area of the top is not the sum of the total surface areas of the cone plus hemisphere. Okay, so here you can note the total surface of the top is not the sum of the total surface areas of the cone plus hemisphere. So now let us move to example number 2. So in example number 2, here we have this figure. Okay, and the decorative block shown in figure 12.7 is made of two solids, a cube and a hemisphere. Okay, so a cube and a hemisphere. The base of the block is cube with edge 5 centimeter, and the hemisphere fixed on the top has a diameter of 4.2 centimeter. Okay, so we have given this decorative block, and here the base of this block is a cube with side 5 centimeter, and the hemisphere fixed on the top has a diameter 4.2 centimeter. So find the total surface area of the block. We need to find the total surface area of this block, and here you can take phi is equal to 22 by 7. Okay, so let us find. So the total surface area of the cube, this is equal to 6 times edge square, and here we have given the edge of this cube is equal to 5. Okay, so the total surface area, the curved surface area of the cube is equal to 6 times edge square, that is equal to 6 times 5 times 5 semi square, that is equal to 150 semi square. Okay, so the total surface area of the cube is equal to 150 semi square, and note that the part of the cube where the hemisphere is attached is not included in the surface area. Okay, so note it down, the part of the cube where the hemisphere is attached is not included in the surface area. So the total surface area of the block is equal to total surface area of cube minus base area of hemisphere plus curved surface area of the hemisphere. Okay, so here the base area of the hemisphere is not included with the total surface area of the block. Okay, so total surface area of the block, this is equal to total surface area of the cube minus base area of hemisphere plus curved surface area of hemisphere, and here the total surface area of the cube is equal to 150 semi square. Okay, so this is equal to 150 minus pi r square, this is actually base of the hemisphere. Okay, minus pi r square plus curved surface of the hemisphere, that is 2 pi r square, so that is equal to 150 plus pi r square centimeter square, and this is equal to 150 times 150 semi square plus 22 by 7 into 4.2 by 2 into 4.2 by 2 semi square, and this is equal to 150 plus 13.86 semi square, and this is equal to 163.86 semi square. Okay, so the surface area of the block is equal to 163.86 semi square. And now let us move to example number 3. So A wooden toy rocket is in the shape of a cone mounted one cylinder as shown in this figure. Okay, so the height of the entire rocket is 26 centimeter, while the height of the conical part is 6 centimeter. The base of the conical portion has a diameter of 5 centimeter, while the base diameter of the cylinder portion is 3 centimeter. And if the conical portion is painted orange and the cylindrical portion yellow, then find the area of the rocket painted with each of these colors. Okay, so take 3.14 centimeter. So here you can see this figure. So total this height is 26 meter, and the height of the conical portion is 6 centimeter, and here the base of the conical portion is actually with diameter 5 centimeter, and the base of the cylindrical portion is with 3 centimeter diameter. Okay, so now denote radius of cone by r and slant height of cone by l and height of cone by h. So radius of the cylinder by r dash and height of the cylinder by h dash. So then r is equal to 2.5 centimeters, since the diameter of the base of the conic cylindrical portion is 5 centimeter. Okay, so r is equal to 2.5 centimeter, and height h is equal to 6 centimeter, r dash is equal to 1.5 centimeter, h dash is equal to 26 minus 6, that is equal to 20 centimeter, and the slant height, that l is equal to square root of r square plus h square. This is equal to square root of 2.5 square plus 6 square centimeter, and this is equal to 6.5 centimeter. So here the conical portion has its circular base resting on the base of the cylinder, but the base of the cone is larger than the base of the cylinder, so a part of the base of the cone is to be painted. Okay, so the area to be painted orange, this is equal to curved surface area of the cone plus base area of the cone minus base area of the cylinder, that is equal to phi rl plus phi r square minus phi r dash square, and this is equal to pi times 2.5 into 6.5 plus 2.5 square minus 1.5 square centimeter square, and this is equal to pi times 20.25 centimeter square. This is equal to 3.14 into 20.25 centimeter square, and this is equal to 63.585 centimeter square. Okay, so the area of the painted orange, this is equal to 63.585 centimeter square. And now the area to be painted yellow, that is equal to curved surface area of the cylinder plus area of the base of the cylinder, that is equal to 2 pi r dash h dash plus pi r dash square, that is equal to pi r dash times 2 h dash plus r dash. This is equal to 3.14 into 1.5 into 2 into 20 plus 1.5 centimeter square, that is equal to 4.71 into 41.5 centimeter square, and this is equal to 195.465 centimeter square. Okay, and now let us move to example 4. So in example 4, it said to us, Mayank made a bird bath for his garden in the shape of a cylinder with a hemispherical depression at one end, that is shown in this figure. Okay, the height of the cylinder is 1.45 meter and its radius is 30 centimeter. Find the total surface area of the bird bath. Take phi is 22 by 7. So here if we let h be height of the cylinder and r be the common radius of the cylinder hemisphere, then the total surface area of the bird bath is equal to curved surface area of cylinder plus curved surface area of hemisphere, that is equal to 2 pi r h plus 2 pi r square, that is equal to 2 pi r into h plus r. This is equal to 2 times 22 by 7 into 30 into 145 plus 30 semi square, that is equal to 33000 semi square. This is equal to 3.3 meter square. Okay, so I stop here this lecture. Thank you very much to all of you.